Like a soaring eagle, Aries Group of companies has flown high in its illustrious 25-year history. The company, which was founded by naval architect and visionary media entrepreneur Sir Sohan Roy in 1998 in Sharjah, has today gained a foothold in the form of 57 companies in 19 countries, affirming the global vision of its top leadership. From founding a team size of just 5 members, the company today employs nearly 2,000 permanent employees. Aries One provides engineering services to the entire range of assets and activities, right from upstream to downstream sectors that define the offshore, oil and gas, and shipping industries. Our team has expertise on engineering services that covers the entire life cycle of assets, from design, construction, transportation, installation, operation, asset management, inspection, life extension till decommissioning.
Hydrodynamics engineering division under Aries One deals with how ships and offshore structures interact in different seas under varying environmental conditions and surrounding fluids. The division performs analysis jobs for safe navigation and cargo transportation, response of vessel motions on surroundings, operability for offshore operations and hydrodynamic responses during marine installations and responsive station keeping systems. Hydrodynamic analysis in general includes various dynamic studies of the floating structures including the ship motions, mooring, offshore operations and installations, resistance and powering, ship maneuvering, subsea operations, etc. The hydrodynamic wing performs a key role within the Aries Group in planning operations for major projects of vessel owners and oil and gas industry clients. Environmental parameters and metocean conditions play a key role in the hydrodynamics of the floating objects. Few of the environment conditions considered are water depth. Water depth of the seas over the world varies from few meters to 1,000s of meters and do play important role in selection of the moorings and also on the wave and current loads acting on floating vessels. Tides, varying. Tides from low tide to high tide are important to be analyzed specifically for quayside and terminal moorings, fixed mooring operations, lay operations, etc. Wave on ships and offshore structures are the key component which eventually estimate the dynamics of these floating structures. The most important part of the hydrodynamic analysis is to estimate the wave load components on the ships, including drift forces, diffraction and radiation wave forces. Accordingly, the location of projects with respect to the weather scenario play a key role in hydrodynamic analysis and limitations of offshore operations. Therefore, further understanding of hydrodynamics can aid in planning ahead for safer marine operations and station keeping. Various job scopes performed under the hydrodynamics team includes mooring analysis. The term mooring refers to the system for securing or station keeping of the vessels. Shipboard operations such as mooring at terminals and quayside moorings, spread moorings, single-point moorings, multi-buoy moorings, emergency towing, tug handling, barge mooring, canal transit, anchoring shall fall into the broad category of mooring and thus require specialized fittings or equipment on boards. Single-point mooring, where a vessel is moored to a single point allowing the vessel to weather vane around the mooring point. This mooring or anchoring can be achieved using anchors and shipboard mooring fittings. Multi-point spread mooring, where a vessel is moored to 2 or more points/buoys. 4 to 8 point mooring shall be common for smaller vessels and barges. However, 12 to 16 point moorings shall be required for larger vessels and installations like FPSOs, tankers, semi-subs, etc. Spread mooring shall be commonly used for mooring near assets and for mooring for specific operations, as these shall aid in limiting the vessel excursions compared to single point moorings. Quayside mooring, where a vessel is moored to a quay, jetty, pier. Quayside mooring are attained using the existing mooring hooks or bollards available at the quay. Fenders are also integral part of this system, which shall be absorbing the vessel loads for the oncoming headings. Turret mooring, which is common for FPSO, FSO type vessels, where the ships are permanently moored with a turret at the midship or forward, while carrying out oil production and offloading respectively. Ship-to-ship mooring, where two ships are moored with each other, common for tanker offloading operations, where the vessels are required to be in close proximity to aid in transfer operations. Expected outcome of the mooring analysis depends on the type of mooring. Offshore mooring analysis outcomes can range from sizing off the mooring fittings on board, capacity estimation of the anchors and mooring lines, etc., determination of the maximum vessel motions, selection of limiting design and operating environments, weather limitations for offloading or transfer operation, and so on. Mooring analysis is also an integral part of design of terminals and quayside jetties, whereby the analysis provide limiting scenarios for berthing, unberthing and transfer operations. The analysis shall aid in the selection of fenders, bollards, quick release hooks and other mooring fittings. Transportation analysis. It includes the motion response analysis during voyages, seakeeping and green sea analysis, towing analysis, etc., where the vessel motions and response during navigation and maneuvering are analyzed. Background for estimation or analysis of various hydrodynamic behavior of ships and floating structures began with ship models testing, which dates back to the 19th century. Today there are various proven and tested approaches and methods which aid in ships' operations and station keeping. Predictions including model testing in model basins, computational fluid dynamics, potential flow/panel, code methods. Aries Marine uses industry standard software in combination with class rules and widely recognized standard guidelines in prediction of vessel motion and responses. Few of the software which are used for hydrodynamic analysis and simulations are MOSES, a hydrostatic and hydrodynamic software for simulation of offshore operations; Optimoor, an easy-to-use mooring analysis software for all types of mooring with inbuilt OSHIMF recommended methods and formulae with the capability to model static, dynamic, wave response, ship-to-ship, tsunami, passing ships and many more. Orcaflex, a comprehensive general-purpose dynamic analysis software for offshore marine systems, which include riser systems, transport, installation and decommissioning, moorings, pipe lays and pipelines, renewables, towed systems and numerous other applications. Hydrostar, an advanced hydrodynamic software for seakeeping analysis, extensively tested and validated through comparison with semi-analytical studies, numerical results from recognized tools and experimental data. Mike, a comprehensive dynamic mooring analysis software which can assess truly and accurately the dynamic effects of wind, current and local wave climate on moored vessels with highly precise vessel response assessment, multi-body interactions, and ability to analyze automatic mooring systems used for port operations planning and design, and also mooring equipment location optimization in shipbuilding, mooring equipment design, and can be also used for design and analysis of oil and gas terminals. Hydrodynamic analysis is performed in line with the recommendations and guidelines, including classification society rules specific for notations and vessel types, industry standard guidelines like API RP2SK, DNVGL STN001, OSHIMF recommendations, PSN recommendations.